Okay, I've set up another experiment. This one's to test the vaginal lensing effect, otherwise known as magnetic lensing. So this one here is the coil we were using before, with the 3 different sizes of stock, as you can see. That was suited for the 30mm. What I've got here is some 20mm stock, and I've wound a second coil. So we can probably see these side by side better from the top, but as you can see, there's far less of a gap in here. So once I apply the same amount of power, we'll be able to make a comparison between these 2 coils, which have exactly the same resistance and exactly the same wire and the same dimensions. So, is the lensing effect relevant? Which is really the only last variable. So let's test it. Okay. Let's get some juice. Same amount of juice. About 45 watts. Okay. Coil's bounced up, as you probably heard. And it may be a little higher than it was before. It feels more powerful than it was before, which is not, it's got quite a bit of bounce to it obviously, which is, so anyway, what I'm going to do now, because I'm actually looking at the screen on the camera and it's a little off-putting, I can play with these toys all day long, but through the screen of the camera it's a little difficult. Okay, anyway, without dropping it or breaking any more magnets, I'm going to shut it down for just a moment and set up the second experiment, which will be this coil with the large hole and the same magnets top and bottom, and the same stock. So I'm going to swap back to this coil with a larger hole, so we'll see if the magnetic field is simply escaping and being wasted, in which case it will prove that what we want to use is a coil and a shaft with an extremely small gap in between. So we're trying to home in to build the most efficient linear motor we can possible, because the belief is that a linear motor of this variety can be more than 100% efficient simply by increasing the size of the magnets on either end. So let's find out how significant the lensing effect is. Alright, be right back with you.